There are two big themes that keep showing up in our conversations with the ecosystem and customers. And so today we are going to go into each of them. The first is, I think we as a community have to completely internalize enterprises will have multiple wireless technologies. So we cannot just live in our own silo and say, hey, we'll keep doing private 5G and that's the end of the world. The reality is it's a multi-wireless enterprise. And not only that, each of these wireless technologies realize that there is this new wave of physical AI coming, and they are all evolving to meet the needs of that. That has implications on how we think about this. And so that's the number one thing we're going to go deep into. And the second is going to be how do we develop the full ecosystem all the way from devices to data solutions to eventually intelligent solutions in this layer focused on the industrial enterprise. And we'll go deeper into that. But before we go into the second one, I'm actually going to double click into the very first one. And as I said, we have, in fact, in that 30-minute conversation, I think we heard everything other than private 5G. I was actually trying to keep track, and I don't think the words private 5G showed up in that. We actually talked a lot about Wi-Fi. We talked a fair amount about where the public networks were going and what neutral hosts could be doing. And the new kid on the block that we started alluding to, but it will come out more as you go through the day, is now NTN and satellite. So I wanted to take a step out of the private 5G silo that a lot of us in this community live and actually listen to people who are coming from all of these worlds and just get a sense of how are these wireless technologies, these wireless ecosystems evolving themselves in the context of this big AI wave that we are all talking about. So in that context, I would like to invite, maybe first off, Anna Osa, who's joining us. She's Senior Director of Product Management in T-Mobile for Business, and she's going to be joining us in this panel. Joining her is Brian Zemekli, who is Senior Director of the US Enterprise and Government 5G Solution Sales. Again, works a lot with enterprises of all types, has a lot of expertise in this area. We also have Charles Matthews, who is SVP of Strategy of Alcatel-Lucent Enterprise, one of the top enterprise Wi-Fi companies. They are also a reseller of the Celona private 5G solution. And if I may say so, they are the only real company who can actually give you a converged view of Wi-Fi and private 5G today. Not enough people know, in my opinion, about that. And then, as I said, the new sexy kid on the block is Madan. Not you, it's your technology. Maybe you too, how about that? But Madan Angapura, who leads product at Skylo, which is an NTN and satellite technology company. And so to help have a discussion with all of them, I actually think there is nobody better from a private 5G community, because this person probably has more scars of trying to bring private 5G to the enterprise than any of us, and that's my co-founder and CTO, Mehmet Yavuz. So Mehmet, if you don't mind joining us on the stage. And I'm going to hand it over to them to have a discussion.
Thank you, Rajeev, for that great introduction. And Madan, I'm sorry, you may have stuck with that thing for a while now.
Yes.
Thanks everyone for coming. I'm so excited today. We have such a unique panel. We have a great topic to discuss, different perspectives. First, I want to give everyone a chance to introduce themselves in a little bit more in terms of what you do, what your role is, and so forth. So, Anna, can we start with you?
Of course. Good morning, everyone. I'm Anna Osa. I lead a product organization at T-Mobile for Business. We are the complex networks organization where we put products out there that are connected internet, so business internet, 5G advanced network solutions where we deliver network slicing, private hybrid networks, T-Platform, which is a platform that allows you to orchestrate all of your services from a single pane of view, and public safety solutions as well.
And I'm Brian Zemekli. I lead private network and neutral host network sales, as well as edge compute for Verizon for the US, everything global enterprise and public sector. I have teams across the country. I think I up Robert Greiner by a year. I've been with Verizon for 32 years, so my entire career. And by the way, I want to hire Robert. I tell you what, I mean, is there no better approach than what the hell are you waiting for? Because to me, I was at the 5G Alliance too, and I heard Robert speak, and I think he's just outstanding. So great to be here.
Good morning, everyone, and Mehmet and Rajeev, thanks for having us here. It's a pleasure to be part of this panel. I'm Charles Matthews with Alcatel-Lucent Enterprise. I head up our portfolio strategy across our enterprise networking portfolio as well as our communications portfolio. We do collaboration and legacy communications and an enterprise equipment. We are, as Rajeev said, we're super excited to have brought Celona into our portfolio because we're trying to connect everything everywhere. So when Robert was talking about the enterprise sales folks not being able to talk 5G as well as, say, switching or Wi-Fi, we're hopefully overcoming that now and building a completely integrated solution. Alcatel-Lucent Enterprise, I'll cover this one real quick. Alcatel-Lucent, we thought it went away with Nokia, is probably what a lot of you are asking. So before Nokia, Alcatel-Lucent spun off its enterprise division, much like HP and HPE. So that's where I come from, is the enterprise part of the old Alcatel-Lucent that is now part of Nokia. We all know the musical chairs in our industry, but that's where we sit.
Yeah, hi everyone. I'll lean into what Rajeev said. I'm the new kid in the block to this community and to this session, and we are the fourth pillar in this connectivity. So I lead product at Skylo, so we're based in Mountain View. Skylo, for those of you who don't know, we basically offer satellite connectivity to IoT devices. If you have a Pixel Watch or a Samsung Galaxy smartphone on a Verizon SIM card, we essentially are the company behind being able to send emergency SOS and SMS. We work with a very large set of ecosystem players, chipset module makers, device makers, to kind of certify their devices to be compatible. So we'll talk about that a little bit. And we operate at about 37 countries and rapidly growing to more. So again, my intention is to actually just share what this fourth pillar can do. Again, it is very, very complementary to what you're all actually thinking. So I hope if there is one takeaway is keep that fourth pillar in mind, and we'll chat more.
Thank you again, all of you, for joining us. And as you can see, we have the expert panel here for all the different pieces of the wireless puzzle, the way I look at it, right? From the cellular, public, private, to Wi-Fi, to NTN. We have all these different components. And today, Rajeev opened up the conversation with the physical AI. Right? That's the kind of new transformation change that we are seeing all happening in front of our eyes. And I like to kind of separate the discussion into two parts. In the first part, I like to go into how each of your world evolving to kind of feed into this physical AI enterprise space. And then in the second part, we'll talk about how do all these technologies work together. Right? How do they converge? How do the end solutions kind of get into the enterprise space? And then we'll have some time for Q&A. So please start thinking about your questions at the end. As much as time allows, we'll have Q&A. All right, so I want to first start with Yana. Of course, T-Mobile has been driving the 5G standalone network slicing T-platform. It's a nationwide offering for all the enterprises. And it's very exciting in that regard. And T-Mobile has been very vocal about AI as well, right? Edge AI, AI grid, and physical AI coming together. So how do you see the T-Mobile for Business platform evolving in this new world?
Absolutely. And just to put a finer point on how many musical chair motions we've done in this career, I have worked at Verizon. I have worked at Alcatel-Lucent, and I haven't worked at Skylo yet, so we'll see where we go.
Awesome.
So physical AI broke down one of the key tenets on what networks were built on, and is the notion that latency is negotiable. In a world where you have cloud AI or SaaS or video conferencing, a few 100 millisecond latency, no problem, it still works. But when a robot is trying to decide whether to stop, or a safety system, a vision safety system, a factory floor needs to identify a security issue, a few hundred milliseconds doesn't cut it. We're talking about single-digit millisecond latency, and it has to work all the time, not just on a good day. So that changed the perception and the engineering work that we have to do at the network side. So our CTO, John Saw, calls it kinetic tokens, because in physical AI, data is actually driving physical outcomes, not just describing it. So the foundation to address that is 5G standalone. We bet big into 5G standalone. We deployed the first nationwide standalone network in 2020 because we understood that's the foundation under which you can build network slicing, edge orchestration, cloud-native cores. And with that, you can then start relying on things like network slicing. Network slicing is the first advanced feature that has come to market in the incarnation of T-Priority. T-Priority was the first nationwide network slice dedicated to first responders. I think everybody in the room would be happy to know that first responders are getting the most resources in the network in those times of need. And a network slice is giving them the ability to now have the 5 times the resources than anybody else in the room for an emergency. You evolve that now with a product like Super Mobile. Super Mobile is bringing network slicing into the enterprise so that those critical applications can happen just like they happen for first responders. When you look at other capabilities of 5G standalone, now we can talk about, last year we introduced L4S, low latency, low loss, which now dynamically and proactively is managing congestion because that robot system can't wait for the congestion to happen to start addressing it. L4S can dynamically and proactively manage that congestion. And then you think about other problems that physical AI is reliant on being solved is data. What happens when the data now leaves the device? Does it have to go to a distant data center? Does it have to be exposed? And the answer is no. When you have solutions like edge control. Edge control is a local breakout that allows the data to stay local on your premise so that you have a lower path, lower latency, less path to travel, data security. So now you can start seeing how all of this comes together for physical AI built on the foundation of a 5G standalone network. And the next step is where do you do the compute? So we've already started looking at can the AI compute and the connectivity coexist in the same infrastructure? And the answer is yes. We've already started testing at our AI RAN Innovation Center, and we've proven that those two loads can coexist in the same infrastructure. So this year, we're rolling out 4,000 new cell sites that can be edge compute candidates. And that's how physical AI has transformed how we think about networks.
Thank you. Thank you for that.
The answer's not near that good. We could just skip me.
Well, I can see that, but I also know that Verizon has been really a leader in the enterprise services space, right? And you guys have been one of the first in terms of bringing private 5G into the cellular space. And this journey that started with MEC Mac, going into AI and so forth, I think we are all curious to see how the Verizon Business Group is looking at this and how we are approaching it.
Yeah, good. So, you know, Rajeev kicked off his piece this morning showing the layers. And that's exactly the way we see it, the same way. We call it the layer cake, which is, by the way, my downfall. Love cake. Where the foundation is the devices, that's your physical, right? That's the way we see industrial, same thing. Upper layer being the AI, right? So your engines and your platforms. And then the middle, the models, the middle being the transport. Now, that's typically where we sit. And we've been pretty good at it over the years. I think both organizations building this foundation of networks. So the amount of fiber we have across the country that we've spent billions of dollars building over the years, it's everywhere. We're in the middle of making that fiber better, doing some upgrades. You have the private, or you have the macro 4 and 5G network that a lot of us enjoy today, expansive, constantly getting better, new iterations. And then now you have private. So for the last 3 years, we've been obviously selling private and installing private networks for our customers, both indoor and outdoor. So I think the foundation has been laid by all three carriers, honestly, right? But I think it's our responsibility as a carrier, and it really is a responsibility, to continue to make things better, to continue to make the network better, more reachability, lower latency, faster pipes, right? More throughput, more bandwidth. Because without that middle layer, the entire cake collapses. So that's table stakes. And that's not only in the macro network build out and everything we're doing there, but also in private, right? So we bring connectivity, we bring private connectivity. We do a lot of neutral host, by the way. We do a lot of it. And we do a lot of it in carpeted spaces. But that whole piece is our responsibility to continue to make better. Where it becomes exciting is when you add intelligence to the network. Now, we haven't been dumb pipes for all that long, but if you look back 10 years ago or more, that's what they were. They were dumb pipes. But now through our AI Connect initiative nationwide on our network, we're bringing that intelligence to the network, that self-healing, that predictability, to understand when something's about to fail. Similar to a manufacturing floor with predictive maintenance, we're bringing those smarts into our network. And from a private side, right, we're bringing intelligence there through AI Connect to the private environment, being able to understand exactly where that device is at using precision location, knowing when that signal strength is going to start to drop before it actually drops off, and then knowing what network is available to take its place ahead of time. So again, it's bringing all this intelligence to the network. That's, I think, the most exciting evolution that you're going to see, both in the private as well as the macro space.
Awesome. And Charles, ALE, of course, you guys have been on the forefront of Wi-Fi, right? Wi-Fi 7 came out. You now even have a ruggedized outdoor Wi-Fi 7 solution out there, and you have a lot of experience on that. And we had some earlier conversation about Wi-Fi. Wi-Fi is basically there all the time. And the question, I think, is how is Wi-Fi evolving for the physical AI, right? I think folks are hearing two different things. On one side, as we heard from Robert Greiner, some people saying, okay, like for these kind of AMRs and so forth, Wi-Fi may not be the good fit, right? But then there's always, okay, Wi-Fi 7, Wi-Fi 8, those advanced features coming in. So I'm really curious, what is your take in terms of, in this physical AI space, how Wi-Fi is playing and how it's going to play?
Yeah. The cat out of the bag, we think that Wi-Fi and private 5G, they coexist in the same world. And I agree with Robert, Wi-Fi probably is not going away, but needs to be blending with 5G much more. So when we look at Wi-Fi and private 5G, we're also looking at a whole ecosystem, because for us, when we're looking at this industrial AI world, I mean, we cut our teeth in industrial Ethernet, say 20, 25 years ago. So we have to think about not just, when we're talking about Wi-Fi and private 5G, we're talking about the network edge for the most part. I mean, a lot of our discussion here today is going to be about the network edge, but as a provider for the whole network, we have to think about the edge as well as going all the way back now to the data center. So if we're adding, Wi-Fi is an important piece there to collect the data, we need to bring it in quickly, securely, and we're really aiming to get the traffic onto our fabric as quickly as possible. So if we're trying to connect everything everywhere within the enterprise network, we're thinking about all different pieces, not just Wi-Fi. And when we talk about the AI side of things, we're thinking more and more about, as Em was talking about, compute and networking together. We're switching a lot into, should we even get into compute? So this is becoming more and more on our minds. At the data center side, we've got, we're not exactly in a Arista out there, but we've got to be thinking about 400 gig connections and connecting from the device all the way to the core. That's really our goal. So that's the connectivity part of the stack, so we're thinking about that. We'll think in terms of connectivity, security, visibility for the most part when we're looking at all this. And with Wi-Fi coming in, it's got to be coming in securely. So of course, we've got our zero trust architecture in place, network access control. But as Robert was talking about, we're trying to get, whether it's a private 5G connection or a wireless connection, we're trying to get it into our fabric as quickly as possible, because that's where we're going to be segmenting the network, particularly for the OT devices. Robert was talking about administrative and protected networks, and that's really how we think of things as well too, how our customers are thinking about things. So we want to get them on our fabric, secure the protected, put wrap QoS policies around it that are appropriate, and build from there. And finally, the third piece of the stack pillar is the visibility side. And this is where, like most vendors in our market, we're moving beyond just regular network management into an AI ops infrastructure. So this is where not just visibility, but intelligence about the network is coming into play. And it's not just as simple as just giving telemetry on devices and our own equipment out there, but we've got to start making sense of it. And we've got to do it safely and securely. So we've got plenty of, a lot of our customers are in what we call mission critical industries, so they want to be careful about their data. So a lot of times they don't necessarily want cloud. So we've got to be able to do AI ops on site for these customers, particularly in Europe with a lot of the data privacy laws and CRA coming into play this year. Security is really key. So we've got to be able to offer AI ops both in the cloud as well as on site. We call it our OmniVista Cirrus and OmniVista Terra. So we've got to be doing land and air overall. So visibility, security, as well as connectivity is what we're thinking about in this the brave new world of industrial AI.
Got it. Perfect. And Madan, I think these last 18 months must have been like a dream for you guys, because there is, like every other week, there's another news about NTN, right? Non-terrestrial networks, and there's all these LEOs and different solutions coming out there. And I think we are all familiar with the backhaul aspect, right? It starts from residential backhaul. Lots of enterprises are now using satellite backhaul as a redundant backhaul. But there's another piece which is also very exciting, I think, which is mobile devices, right? More and more mobile devices are now supporting NTN, starting with smartphones, but now there are modules and other things. So how is that world evolving for the physical AI?
So a little bit of a satellite 101. In order for things to actually work, of course, it's the fourth pillar of connectivity, as I keep saying. You have to have a number of things in order to actually make it a reality. Number one, you have to have chipsets that actually support different frequencies in terrestrial, but also the satellite has its own sets of bands. Those bands are homologated worldwide, called as MSS, called as L and S band, and there are a few others as well. And then, in order to offer a particular service in a given country, you have to have what's called as landing rights. After that, you have to have birds in the sky, what we call, probably equivalent is towers or cells locally. And then you have to have a network, very similar to the terrestrial network if you are familiar with it. We have our own NTN network, similar to we have our own RAN, we have our own core. And then more importantly, you have to actually bridge that gap into the terrestrial world, which means, for example, we and Verizon actually integrate. What that basically does is, now let's go back to any device, an IoT device or a smartphone. that devices have Verizon SIM in them. You could imagine a world that I am here, I am in cellular connect, in wireless connectivity. I'm taking a phone call, or I'm actually like doing a connectivity action. I go out of here, I switch seamlessly to cellular, and from there probably I am going for a hike where there is no cellular connectivity, and there was no drop, but the user did not understand the underlying technology. Everything was seamless. So we are transitioning from a world of where we are, which is like break before make, to make before break, which means mobility is going to be really important, and you will not actually see any drops before you transition from one radio access technology to the next. So that's the mental model. Now the same actually goes for like IoT devices as well. We talked about D2D, which has been the most in the press. But the reality when it comes to industrial AI is there are certain scenarios, certain use cases, whether it's catching a salmon in some part of the country and wanting to actually like track the cold storage sensor data all the way through the shipment, through the maritime, through the port, and into a warehouse where you can already see that it transitions from Wi-Fi to satellite to cellular to Wi-Fi back again. How do we make sure that there is this multiple of these connectivities is seamless to that sensor device? So I think this came up earlier that you will actually see the underlying chipsets supporting multiple of these RAD technologies. And then there is a connectivity layer that touches all the 4 pillars. And then you will have applications that sits on top of it. And to be clear, each of these connectivity pillars have their own characteristics in the amount of throughput that they support, in the latency that they offer. So I guess the application will have to be a little bit aware of it, and each of them will evolve over time. These are all complementary. I don't expect one replacing the other 3 in any shape or form.
Yeah, absolutely. And I guess this is blending into the second part of the conversation, right? How all these technologies are working together. And maybe I'll just follow that thread that you started. And maybe we can go in the reverse order this time. So in your experience, bringing all these technologies into one convergence layer for connectivity, you have to work with different device vendors, module makers. How was that journey? Like, where are the bottlenecks in that? Can you share some of that? I think that's very relevant to the folks here.
Short answer, long and hard. So we have been actually like working with our ecosystem for almost like 3 to 4 years at this point. So I'm happy to say that the work that we started there is starting to actually like bear fruits. By that, what I mean is on the smartphone side or on the IoT side, the core critical component that you start with is chipsets. So we work with Qualcomm, MediaTek, Samsung System LSI, and many others on the IoT side like Sony, and that's the foundation. They are all starting to actually like realize that they know at this point, but they are starting to actually have a wide aperture of use cases. So which means they are starting to support multi-RAD. You will start to see that convergence of all these RADs being supported by a single chipset. When it gets to IoT, now the module makers are actually like adopting it. I think one gentleman here talked about RedCap. So you're going to see a lot of these things being supported by a single chipset. And we are starting to see more choices now, like probably 2-3 years ago. Satellite was more about like what was satellite to why satellite to now how satellite. Another metric that I actually use is number of booths in MWC that talks about satellite. So it's gone more than 50% or even more nowadays. So now everybody is thinking about like, I would call it as really how phase, where they are starting to actually like invest and adopt. So the first thing that you will see is now there are choices that you can actually like use in order to get the device. That is the most foundational thing. And once that is done, then it's really about like, okay, how do we make sure that for customers like yourselves, with folks that are actually putting things together, how they can actually like make it seamless? How can you basically have a single entity that converges all the 4 pillars and make for the customers like connectivity as a seamless layer and abstract out the complexity of it?
Got it. Charles, Wi-Fi devices, selecting Wi-Fi versus cellular is, I think all of us have a lot of experience in that. And every device does honestly something a bit different. And even within the Android ecosystem, device behaviors vary quite a bit from device vendor to another. So again, in this multi-wireless world, how do you manage this for your customers, right? If a customer expects a certain quality of service from certain devices and applications, like how can you control the device ecosystem behavior and ensure that end-to-end?
Yeah, it's a great question. We're looking to, when we're looking at the whole ecosystem, working with Celona, for example, and many device vendors out there, we're trying to give a seamless experience across the board. If we're looking at just say the private 5G part of it to make it similar to the experience on Wi-Fi, we've already integrated Celona into our management platform. So single sign-on, it's there. If you authenticate on Wi-Fi, you authenticate on private 5G, same, you're in the network fabric. We apply QoS policies, quarantining, whatever needs to happen. That's done. We've also integrated topology, inventory, alarming, notifications, all that's in there. Rajeev, I don't know if we've talked all about this, but we're all completely integrated. And we're working on integrating even at the, what our application is called Network Advisor, which is our AIOps platform. So that's a big piece right there. If we're looking at, so that's the solution. And so for us, we want to get everything into one seamless, unified management plane. When we first adopted, say, Wi-Fi 20 plus years ago, we moved toward an architecture that we called unified access. So this is just however you come in, you're going to have a single network profile, whether you're a device, a human, mobile device. You're gonna come in. We're gonna know who you are, and we're gonna apply certain QoS characteristics to you, put you in the right VLAN so that you're completely controlled there. At least your access is controlled. So that's operating within the enterprise network. So now we've evolved to a point where when a device comes on board, where we see it, we identify the device. If we understand what it is, we'll say, okay, you're a door lock, you're a video camera, you go into this VLAN with these particular policies. So we've got that seamlessly cut through. 5G is really helpful because with microslicing, it's really the same kind of thing. We can take the microslice and then we map that onto a VLAN, right? Very simple. So one seamless experience is what we're going for. There's so many devices out there. We're working closely with, Digi is one ecosystem partner that we look at. They're super great and just covering all different protocols, legacy and otherwise. But in the end, we're trying to fit it into, get it onto our fabric, get it into one management plane that we can operate with. So that's private 5G and the Wi-Fi. If we look at the public carrier network, there's Passpoint and Open Roaming out there, which we think is great for, say, guest access. We see it a lot in our hospitality customers. Of course, we support it across our Wi-Fi products. So this kind of gets you in there with you're eliminating captive portals. So you're a known entity within our network. So you can move from public to our private networks really easily. But for the most part, that's like guest access. Once you get into the network, and when we're looking at our devices and our people within the network, this is when we're relying on these, what we call universal network profiles. So just trying to apply the same profile QoS architecture to everything within the ecosystem.
Got it. Perfect. And Brian, maybe coming next to you, in terms of your offering where you have the VBG solution to the enterprise, and this device can work pretty much anywhere, right? And you have a security profile, you have the performance that you may want to guarantee for that device. And from Verizon perspective, I mean, in the early days, CBRS was really, the device ecosystem was really driven by Verizon. When Verizon said, okay, we want this band, this kind of behavior, many device vendors made it happen. So similarly, there is always Wi-Fi offloading policies and so forth. So Verizon has, also T-Mobile has a lot of influence on the device vendors, right? And how do you see that shaping this new world in terms of device policies for this multi-wireless policy, connectivity, and so forth?
Oh, let's see. That is a big challenge. I can tell you that the device ecosystem is not anywhere near where we would like it to be today, right? Now, that doesn't mean that we can't outfit devices with dongles and, there's a company, I don't know if any of you are familiar with HMS, industrial routing, but they make a bolt device. It looks like about the size of a hockey puck, and it literally screws into a robot with a doorknob, drill bit, super easy, power over Ethernet, and you're up and running on 5G. So we can do those types of augments, and we're seeing a lot more of those solutions coming to fruition. But I can tell you it's still a big challenge. My wife, interestingly enough, is the director of membership for an association called A3. So it's the Association for Advancing Automation. So she knows all of the robotics vendors, and she knows all of the leadership from Otto and Fanuc and KUKA and Mir and all of them. And the one thing she continues to come to me with is she's like, listen, I talk to these robotics companies, and they don't even talk about 5G. They go to Automate, they go to these shows, and it's not even on any of the boards. And I tell my wife, I say, Amy, I said, listen, I said, if they started to admit that Wi-Fi wasn't working like they had thought it would, they would cannibalize their own business. I said, there's going to be a very natural transition. And I think that the point that was made earlier by Robert, why not do both? And so we joined that association Verizon did this year. Celona's a member, there are many others, to promote embedding 5G. And we're certainly here to help, but I'll tell you one thing, we need everyone's help to do it. And this was one of the asks at the 5G Alliance when I attended. I hope in, say it again? Is your wife here with you? She is not here with me, Rob, I know. But I would love to introduce, I would love to introduce you to her. But I can tell you we need your help. And I think, Robert, when I was at the 5G Alliance, that was one of the messages, was, hey, listen, we need you to go promote, from a company and enterprise standpoint, getting embedded devices into the ecosystem. I was out, this is kind of a side note, but I was out at Lake Nona for the Impact Forum a month ago, meeting with hospital systems. That's interesting, right? Just as complex an environment, if not more, with IoT everywhere. And another environment that needs Wi-Fi, frankly, for probably an awful long time, right? But they themselves are working with Baxter and Stryker and GE and Philips to try to get them to move forward to embed something. And the device lifecycle in the healthcare space is so long, it's like designing a model car 3 years ahead of time to get something in it. You have to be forward thinking. But so the bottom line is, we can augment, we can make it available, we can get things enabled, but it'd be so much nicer if we could all work together to get these device manufacturers to put it in their devices on the onset. So.
That's a great point. And I think we are all repeating the same thing, that we need to work as an ecosystem together to kind of drive the same vision for this physical AI with the cellular connectivity for those devices. Okay, Anna. I want to close with you. You guys have driven the network slicing concept with the 5G standalone nationwide network, and a big dependence there is the device support as well, right? So I assume you're painfully aware the
Oh, yes.
device ecosystem there. So how was that journey? I'm curious about. And also, how do you see it evolving in terms of supporting the other connectivity needs of the enterprise customers, right?
Yeah, so you mentioned we have a lot of influence in the ecosystem to some extent because there is a cost associated with that. We talked about in IoT, there aren't that many IoT devices ready for 5G. RedCap is starting to show up, but the conversation goes back to 4G is good enough for my IoT use cases, and the cost of the modules makes it unattainable at this point. So let me stick with what I have. And that's where technology like seamless transition between 5G, terrestrial, and satellite connectivity, it's helping democratize access to that multi-network experience. So T-Mobile has already available a T-Satellite, which is satellite connectivity that you can seamlessly experience it either on your smartphone. It also can extend to devices that are IoT-based devices. Same device that is in your pocket, you can take it to the 500,000 square miles in the US that no cellular network will ever touch because it's just not fiscally responsible to put a tower in the middle of a mountain pass, but satellite can cover that. And when we talk about network slicing, I control how I can enable it from my network and make it available from a network perspective. But it depends on the device being able to route traffic through that slice. So routers, we're working with routers manufacturers on how can I do traffic steering so my point of sale traffic, which is critical for my transactions for my business to continue to run, to go through, but the guest Wi-Fi doesn't consume part of that same spectrum that is so critical. When we talked about T-Priority and Super Mobile for first responders and enterprises, respectively, it relies on 5G standalone capable smartphones that can help us identify that traffic and give it the right prioritization. So it's a labor of love working in the ecosystem on providing the vision of here's where we can go if we all march in this direction, and in the meantime, making that network experience seamless, whether it's connecting to 5G first, satellite backup, Wi-Fi for offloads, and somewhere in between.
Awesome. All right, thank you again. I think we have 5 minutes for questions. Thank you, Ksenia. So I'd like to open it for questions from folks, and please don't be shy. And when you ask your question, please let us know if it is for a specific person on the panel or for the whole panel.
You're talking about basically making devices work together in private network, right? Talk to each other, interoperability, connectivity. How important is it for devices to be able to talk to each other and work across a vendor-neutral ecosystem?
Maybe just for clarification, when you say device talking to each other, it's not device to device, right? In general, basically different types of devices being able to connect, right?
You got your radios, and then you've got your end-user devices, like maybe a dongle, or maybe the phone itself, and then the transmitting. But they're all different vendors, right? They're all different OEMs, okay. And they all have their own nuances, and you have to do things. You know, you might be working months on a problem, and it's just a small thing. Like we had an issue where we had a 3GPP issue between our devices and a radio, not Celona, but a radio that they were trying to connect to, and all the while that radio owner was blaming us for the problem for our end-user devices when it ended up being a release, like our devices are on a different release of 3GPP than theirs, so something like that.
Got it.
Yeah, happy to take a first crack. And so we introduced the term in MWC called as like standardized Sky. And the basic premise is standards. We heavily rely upon like 3GPP standards. And that's what we believe is a best way for the entirety of the ecosystem. both on the transmit as well as the receive, both uplink and downlink on the satellite side is what we think is the best way to actually like move forward, which really addresses the question of like interoperability. Like it doesn't matter which chipset maker, which module maker, which device maker. Fundamentally, they don't have to actually coordinate with each other, but as long as they adhere to the standards, we expect them to actually like interwork. The glue layer is obviously like certification programs and things of that sort that allows to make sure that whatever that you claim as standards do indeed are actually like met. So there is a little bit of trust but verify that generally works in almost like anything that requires like interoperability. But having said that, there will always be challenges, so we'll have to actually like go through them.
Go ahead, Fred.
Yeah, so I'm going to take a little different spin on it here. I think standards is certainly important across all access technologies. I get that. Where I think I heard you also say is how are we looking at device orchestration across OEMs? So that is probably the second biggest challenge. I was with one of the larger logistics companies in the world last week, and I said to the vice president of automation for the globe, I said to her, I said, so Caitlin, what are you doing about device orchestration? I said, you have 4 different robotics companies running around this floor, this 300,000 square foot warehouse, and you're looking at humanoids, which they are, and I mean very real looking at humanoids. And I said, how are you orchestrating one, not running into the other, the Oceaneer robot not hitting the Red Viking robot, and what's going on there? She said, I'll tell you what. She said, we've tried several, nobody's doing it. Nobody's doing it right. And so what they're stuck with, and what they continue to be stuck with, is multiple dashboards. It's kind of like a doctor trying to access multiple dashboards. You'll never get a doc to do it. They want to get to the EMR, they want to get to Epic, and they want to get all the information fed into one spot. In the industrial robotics space, OEM orchestration and conductor type mentality, no one's doing it yet because no one wants to release their APIs. No one wants to give up the ownership. So it's something we're also going after helping solve.
Thank you so much for joining us. This was a great discussion. Thank you, everyone.
Thank you.
Thank you.
Thank you.
Thanks.